Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9. We have been tasked about Chapter 10, Carboxylic acid and derivative. Okay, we have 5 members in this group. First, Saidah Kharina binti Roslan. Second, Nawal Farhani binti Nizamuddin. Third, Nurain binti Sya'a. Fourth, Muhammad Amirul Muklis bin Ahmad Lutfi. And the fifth is me, Muhammad Firdaus bin Ahmad. For the group 9, we have been two tasks, and the first task is about synthetic and reaction of the organic compound. The question, as you can see on the screen.
So in this slide, I will show you the structure of compound A, B, and C. Okay, if you can see the reaction here, is that in the question that alcohol A will react with bromine water and produce white precipitate. So this reaction, one of the chemical test named phenol test. So if you can see the reaction here, phenol will react with bromine water and produce 2,4,6-tribromophenol, and this compound gonna form white precipitate. So from the reaction here, we can immediately note that alcohol A it is a phenol. So uh, alcohol A will react with acid B, which is we get butanoic acid, and produce an ester phenol butanol. So how can we know this acid B is a butanoic acid? Okay, in the question is that this reaction will produce um, sweet smelling organic liquid, which is it has 10 carbon, 12 hydrogen, and 2 oxygen. So the general formula that has 2 oxygen, it is an ester. So to produce an ester, alcohol must react with carboxylic acid. So right now we know this is carboxylic acid. So how can we know this carboxylic acid has 4 carbon? Okay, this compound is that it has 10 carbon, and phenol it has 6 carbon. So 10 carbon, we minus it with 6 carbon, and um, we get 4 carbon left. So 4 carbon, and it is a butane. So 1, 2, 3, 4, and it's carboxylic acid. So we name it as butanoic acid. So how can we get this compound, phenolbutanol? So in this fraction, uh, in alcohol, we're gonna cut the bond of H plus between O and H, and we in butanoic acid, we're gonna cut the bond here, and we combine all these two and produce phenol butanol.
Okay, for this slide, I will explain how compound D can be produced. Compound D is a butanol. Okay, when acid B undergoes on catalytic hydrogenation, acid B is the carboxylic acid. Carboxylic acid, as we know, carboxylic acid can be reduced to the primary alcohol. So the carboxylic acid, which is butanoic acid, with the reagent H2 or nickel or platinum and palladium, it can be produced the primary alcohol that is butanol. Okay, I will explain how compound E can be produced. Okay, compound E is the alkyl chloride. Is the derivative of carboxylic acid when OH here, OH group in carboxylic acid is substitute by Cl, and the reaction of the butanoic acid atau or carboxylic acid with the reagent COCl to thionyl chloride is one of the chemical tests of carboxylic acid, as the reaction give up the acidic white fume. So we can see here the observation of the reaction of the acid react with thionyl chloride can produce the acidic white fume, that is hydrogen chloride gas. Okay, that is how compound E can be produced. For the last compound, it is a tertiary amide, another derivative of B. The tertiary amide can be produced when the butanoic acid react with N-methyl ethanamide, and it produce the tertiary amide. It is N-ethyl and methyl butanamide. Okay, how N-ethyl and methyl butanamide can be produced? That is from the OH group of carboxylic acid is substitute with the amino group. So the amide is the derivative of carboxylic acid that contain amino group, and we need to memorize this is the major product here, and ethyl and methylbutanamide, and H2O is the minor product.
Okay, today I would like to present to you about the enrichment compound in order decreasing reactivity. So we can see here, compound B is the most reactive one, followed by compound A and then compound D. So B is butanoic acid, because there has COO here. So B is the more acidic than A and D, because B has carboxylic ion of resonance stabilization. So the electron in carboxylic ion are localized between the two oxygen atoms here. So the next one is compound A. Compound A is phenol, because there has O here. And then A is more acidic than B, but A is weaker than B, because the stabilization of the electron only inside the benzene ring. So in phenazide ion of phenol, the electrons are localized in the benzene ring. Now I will tell you about the compound E. Compound E is a butanol, which is we can see from this diagram. Compound D is less acidic than B and A, because D has alkoxide ion, which is alkoxide ion has no resonance structure that make it less acidic. So compound D is the less reactive one compared to the compound B and compound A. So from this arrangement, we can summarize that the electron in carboxylate ion is localized between two oxygen atoms. The carbonyl group consists in B is an electron withdrawing group EWG, which is reduce the electron density of hydroxide ion, making the bonds becomes more weaker. So compound B is the most reactive, compared followed by compound A and then compound D.
So today, I will present you task 2, which is ionic component assessment. So the functional group presented is carboxylic acid, and we choose grape. The related Quranic verse, we can find it in Surah Al-Mu'minun, the 19th verse. So the verse is as shown in the slide, and I will read the translation. And we brought forth for you thereby gardens and palm trees and grapes. One of the components in grape is methyl 2-aminobenzoate, which give a grape scent. So methyl 2-aminobenzoate naturally occurs in conquered grapes, and we can find it around 33 parts per notation. It is a clear to pale yellow liquid with melting point of 24 degrees Celsius and boiling point of 256 degrees Celsius. It has a density of 1.168 gram per volume and a refractive index of 1.583 at 589 nanometer of wavelength in 20 degrees Celsius. So methyl 2-aminobenzoate shows a light blue violet fluorescence. It is very slightly soluble in water, but soluble in ethanol and propylene glycol. It is insoluble in paraffin oil. It is combustible with flash point of 104 degrees Celsius, and 2-aminobenzoate contains ester functional group, which is a derivative of carboxylic acid. So move to the composition of the plant. 1 cup of grapes, we can assume that it is about 92 gram. So in a cup of grapes, they can provide about 62 calories, 0.3 gram of fat, 2 milligram of sodium, 16 gram of carbohydrates, a gram of fiber, 15 gram of sugar, and 0.6 gram of protein. So in the slide shown a diagram of methyl 2-aminobenzoate.
So I'm going to talk about the benefits of grapes. Grapes contain powerful antioxidants known as polyphenols. These are thought to have anti-inflammatory and antioxidant properties, and one of these is resveratrol. So laboratory studies have suggested that resveratrol may be able to slow or prevent the growth of tumors in lymph, liver, stomach, breast, colon, skin cancer, and also leukemia. So other than that, it also contains water and fiber, which can help people stay hydrated, keep bowel movement regular, and also reduce the risk of constipation. So other benefits of grape is grapes can help to revitalize your skin. In fact, they can even protect your skin from cancer causing ultraviolet radiation and free radicals that can, on a lesser scale, cause wrinkles and also dark spots. So the added vitamin C is necessary for your skin to form collagen, which helps give your face that youthful firmness. So that's all for our topic, carboxylic acid, and thank you for watching.